In this lecture, we're going to cover section 2.3, which is linear functions and slope. So let's start with the definition of slope. And many of you, have already heard of the slope of a line. And I think you associate with the slope different things. I know many of you think, okay, slope is rise over run, right? Or the steepness of the line, and it is. But really what it is because those are just kind of ways to help you remember the calculation, the formula, rise over run, or the change in the y values with respect to the change in the x values. But really, the true definition of slope is it's the rate of change. So it's how the y values are changing with respect to the x values. And when we compare the two or set up as a ratio, it's just the rate of change. So as far as a formal definition, the slope of the line through the distinct points x1, y1, and x2, y2 is, like I said, the change in y with respect to the change in x. So you could think of it as rise over run. And it's really just the vertical change or the difference in the y values between the 2 points compared to the difference in the x values of the 2 points, which is the horizontal change. And in this diagram right here to the right, we could see that if we have these 2 points, x1, y1, and x2, y2, we're comparing the distance that we would have to move vertically to the distance that we would have to move horizontally to get from one point to the next. So let's just practice using the definition of slope in terms of the formula when we have 2 points. So example 1 says, find the slope of the line that passes through the following points. So for A, we have the points 4, -2, and -1, 5. So we could designate the first point x1, y1, the second point x2, y2, and we'll use our formula for slope. So it's going to be y2 minus y1 over x2 minus x1. So in this case, we're going to have 5 minus a -2. So just be careful with the double negative. And then x2 minus x1 is going to be -1 minus 4. 5 minus a -2 is 7. -1 minus 4 is -5. So my slope is going to be -7/5. So the way we interpret that is, as I move from one point to the next, so if I move from x1, y1 to the point x2, y2, I would have to travel downwards or vertically 7 units and then to the right 5 units. So the line is going to be sloping downward since the slope is negative. Let's look at B. So I have the point 4, 10, we'll call that x1, y1, and the point 3, -5, so it'll be x2, y2, and we want to calculate the same thing. So the slope is equal to y2 minus y1 divided by x2 minus x1. So we're going to have -5 minus 10 divided by 3 minus 4. And that's going to be -15 divided by 3 minus 4, which is -1. Negative divided by a negative is positive. So my slope is going to be +15. And since the slope in this example is positive 15 or 15 over 1, think of 15 as the change in the y values compared to the change in the x values, which is 1. So for every 15 units that we increase in the y direction, we increase by 1 in the horizontal or the x direction. So we have an increasing line since the slope is positive. And let's look at C. So we have 2 points again. We'll call them x1, y1 and x2, y2. We want to find the slope. So we're going to take y2 minus y1 divided by x2 minus x1. So we're going to have in the numerator 8 minus 3 divided by -1 minus a -1. So just be careful of double negative again. So 8 minus 3 is 5. Divided by -1 minus a -1 is really -1 plus 1, which is going to be 0. And 5 divided by 0 is undefined. It's not 0, right? This is undefined. So let's talk about this for a second. So the change in the vertical direction is 5. But there is no change in the horizontal direction, right? Because the denominator is 0. So what that means is we have a vertical line because the y value is changing, but the x value is not. It's staying the same. So that must mean we have a vertical line. So anytime we have a vertical line, the slope of a vertical line is going to be undefined because there's no change in the x values from point to point, and we'd always be dividing by 0. So I'm just going to make a note that we have a vertical line. Now let's move on to the point slope form of the equation of a line. So there's different ways that we could represent the equation of a line. I think the most familiar is your slope intercept form, which is y equals mx plus b. But we also have another equation of a line that we could use. Y minus y1 is equal to m times x minus x1. So this is called the point slope form of the line. So we're going to use the slope m, and we could use a point that the line passes through, and we'll call that point x1, y1. So let's practice writing an equation in this point slope form. And I'll write it again over here. So we have y minus y1 is equal to the slope times x minus x1. So look at example 2. Write an equation in point slope form of the line with a given slope that passes through the given point, and then we'll solve for y. So we'll rearrange it so we are in y equals mx plus b form. So look at A. We have a slope of 6, so m is equal to 6. And it's going to pass through the point 2, -5. So we're given a point, and I'm going to call it x1, y1. So now I'm going to plug into my formula. So we have y minus y1 is going to be equal to m times x minus x1. So we're going to have y minus y1, which is -5, is equal to m, which is 6, times x minus x1, which is 2. So just to, rewrite y minus a -5, we write that as y plus 5 is equal to 6 times x minus 2. So if we leave it as is, this here is the point slope form. But I'm also asking to solve for y. So if we have y plus 5 is equal to 6 times x minus 2, and we want to solve for y, let's distribute the 6 first. So we're going to have y plus 5 is equal to 6x minus 12. And in order to solve for y, I would need to subtract 5 from both sides. So we're going to get y equals 6x minus 17. So this is another way that we could write the equation of the same line. It's just a different form. And this form is our y equals mx plus b form, right? We have y equals 6x. There's my mx, where my slope is 6, and then plus -17 or minus 17, right? And that would be my y-intercept. So this is called slope intercept form. Because we're able to identify M and B, right? The slope and the y-intercept when we have it in this form. And just remember y equals mx plus b. That's my slope intercept form. So we're just writing it two different ways. So let's do one more example. Let's look at B. Let's write the equation of a line that has slope 2, so m equals -2, and it's going to pass through the point -8, 4. So we'll call this point x1, y1. And my formula is y minus y1 is equal to m times x minus x1. And now we could plug in. So we're going to have y minus y1, which is 4, is equal to m, which is -2, times x minus, and be careful of that -8, right? Double negative again. So we have y minus 4 is equal to -2 times x plus 8. So that's my point slope form. And I also want to solve the equation for y. So we have y minus 4 is equal to -2 times x plus 8. Let's distribute the -2. So y minus 4 is equal to -2x, and then minus 16. And I'm going to add 4 to both sides. So we're going to get y equals -2x minus 12. And this is going to be slope intercept form, right? Y equals mx plus b. So let's look at the next example. So it says slope intercept form of the equation of a line. And we really already started talking about that above, right? That's y equals mx plus b. Now, what's the difference between the two, right? How come up here I was saying write an equation in point slope form, and then down here I'm saying write the equation in slope intercept form? Honestly, you could go from one to the other. I think it's more practical to use the point slope form when you have the slope and a point that's not the y-intercept. So in part A up here, my point was 2, -5. That's not a y-intercept. My point here was -8, 4. That's not a y-intercept. How do I know if a point's a y-intercept? Well, look here, for example. If I pick a line, I'm just going to draw some random line. You see how it crosses the y-axis right here? That's the y-intercept. The x value is 0, right? If I draw another line and have it cross the y-axis. Now this point is the y-intercept, but again, the x value is 0. So whenever you have a y-intercept, x is always going to be 0, and we'll call the y value b. So when we're using the slope intercept form, y equals mx plus b, m is the slope and b is the y-intercept, and we write it as 0, b. So whenever I'm given a slope and a y-intercept, I would use this slope intercept form of the line because it's really easy to plug in because you know m and you know b. These points up here, I didn't know what b was. I knew m, but I didn't know b because I didn't have a y-intercept. So like look at example 3. A says we have a slope of 4, so m is equal to 4, and we have a y-intercept of -5. So that means that b is -5. So I can easily use y equals mx plus b. Just replace m with 4. So we're going to have y equals 4x, and then plus b, or -5. So that would be the equation of the line that has a slope 4 and a y-intercept of -5. And this is just a typo. This should be part B. So write the equation of the line that has a slope of -2/3. So m is -2/3 and a y-intercept of 7. So that means b is equal to 7. So we're going to have y equals mx plus b. If I plug in, we're going to have y equals -2/3 times x and then plus 7. And that would be my equation of the line. So depending on what information you have regarding the line, that'll determine which equation would be easier to use, which form would be easier to use to come up with the equation. So use the point slope form when you have a point and a slope. Use the slope intercept form when you have a slope and a y-intercept. So let's just review graphing a line. I think y equals mx plus b, your slope intercept form, is the best to graph because you could use your y-intercept as a starting point and then you could use the slope to obtain a few more points. So to graph a linear function when we're in the form y equals mx plus b, first plot the point containing the y-intercept, then obtain a second point using the slope m. And then I would draw one more line, one more point. Usually 3 points is good to form a line. I always say 3 because with 2, if one of them is incorrect, any 2 points are still going to form a line, right? But when you do 3, you'll know if you made a mistake or not, because if they don't line up, then there's something wrong. So once you come up with the 3 points, draw a line, and then you have your picture. So look, example 4. Graph the linear function. So let's look at A. So y equals 3/5 x plus 1. So my slope is 3/5 and my y-intercept is 1. So that's the point 0, 1. So start with the point 0, 1, which is right here on the y-axis, right? There's 0, 1. I'll make this a little bit bigger. And now we know the slope is 3/5. So that means for every 3 units that we increase in the y direction, we increase by 5 in the x direction. So I'm going to go up 3. So 1, 2, 3, and then to the right 5. 1, 2, 3, 4, 5. So there's another point. You can also think of it as starting at the y-intercept, but now moving down 3. So 1, 2, 3, and to the left 5. 1, 2, 3, 4, 5. That's still going to land you on a point that's on the same line. The reason is a negative over a negative is still positive, right? So if I move down 3, -3, to the left 5, -5, it's still equal to positive 3/5. And now I'm ready to draw my line. So that's what the line y equals 3/5 x plus 1 looks like. So I'll do them all on the same graph. Let's look at B and I'll use blue. So y equals 2x minus 3. So m equals 2 and b equals -3. So we have the y-intercept 0, -3. We want to treat the slope as a fraction, right? Because we want to look at the change in y with respect to the change in x. Remember, it's a rate of change. So whenever you have a whole number, just put it over 1. So we have a fraction. So we're going to start at the point 0, -3. And we're going to move up 2 and then to the right 1. Up 2 to the right 1. Up 2 to the right 1. And we could do, as many as we'd like, but this is enough. So my blue line represents y equals 2x minus 3. And then let's do one more. We'll make it green. So y equals -1/4 x plus 2. So my slope is equal to -1/4. And my y-intercept is equal to 2. So that's the 0.02. So I'm going to start with the 0.02, right, on the y-axis. And my slope is negative now, so my line's going to be decreasing from left to right. So we're going to move down 1 and then to the right 4. 1, 2, 3, 4. Down 1 to the right 4. 1, 2, 3, 4. I could have also started at 0, 2. And I could have moved up 1 and back 4. 1, 2, 3, 4. It's the same thing because -1/4 is the same thing as 1 over -4. It doesn't matter if you assign the negative to the numerator or denominator. You just can't assign it to both because then that's really positive, right? So this is what my line looks like in green. So that would be the line y equals -1/4 x plus 2. So that's just a review on how to graph a linear function when we're in the form y equals mx plus b. Now let's talk about the equation of a horizontal and a vertical line. So whenever we have a horizontal line, the equation is going to be y is equal to b, where b is the y-intercept of the line. And the slope of a horizontal line is 0. So for example, look at example 5. I want to graph y equals 3. Notice the x term is missing. That's because the slope is 0. So if I had y equals 0x plus b, it would look like that, right? Y equals 0x plus 3, and 0x is just 0. So this is the same as y equals 3. And so the y-intercept is 3. So I'm going to put the 0.03, and then we have a horizontal line that goes through the 0.03. And the slope of that line is 0, right? Because I'm not moving in the y direction. Y is staying 3 throughout the life of that line. Just the x values are changing. So when I divide 0 by anything, the result's going to be 0. So that's why the slope of the horizontal line is 0. Now, a vertical line can be written by the equation x equals a, where a is the x-intercept of the line, and the slope of a vertical line is undefined. And we talked about that when we did one of those first examples above. But we'll review this again. So if we want to graph x equals 4, plot the point x equals 4, right? Your x-intercept, and it's going to be a vertical line through x equals 4, and the slope is equal to 0. So here's x equals 4, and then in blue is the line y equals 3. So that's how we plot horizontal and vertical lines. There's another form that we could use to represent the equation of a line, and this is the general or the standard form. So we can also write a line in the form ax plus by plus c is equal to 0, where a, b, and c are real numbers. A and b both can't be 0, or else we wouldn't have a straight line. We wouldn't have a line. So let's look at example 7. Find the slope and y-intercept of the line whose equation is in A, 3x plus 6y minus 12 is equal to 0. So this represents the equation of a line. It's just in standard or general form. You see it's in this form ax plus by plus c is equal to 0. What I want you to do is find the slope and the y-intercept of this line. So I would just get the line into y equals mx plus b form, right? Because when we're in this form, we could easily see the slope and the y-intercept. So let's solve for y. So to solve for y, we're going to bring the x term and the constant to the right-hand side of the equation. So I'm going to add 12 to both sides of the equation first. So I'm going to have 3x plus 6y equals 12. And then we want to isolate the y term, right? Because we want to get this in the form y equals mx plus b. So now I'm going to subtract the 3x from both sides. So I'm going to have 6y is equal to negative 3x plus 12. I'm just writing the x term first. And now we have to divide both sides of the equation by 6 in order to have 1y, right? 6 over 6 is 1, so we're going to have y is equal to negative 3 over 6, which just simplifies to negative 1/2, right? 3 goes into 6 twice, so that's negative 1/2 x. And 12 divided by 6 is 2, so plus 2. So now my equation is in the form y equals mx plus b. And we could identify the slope, which is negative 1/2. And the y-intercept, b, is equal to 2. So the point's going to be 0, 2. We'll do one more. So for b, we have negative 2x minus 4y plus 8. So let's start by bringing the 8 to the other side by subtraction. So I'm going to have negative 2x minus 4y is equal to negative 8. Now let's add 2x to both sides. So we're going to have negative 4y is equal to 2x minus 8. So we have negative 4y equals 2x minus 8. And now we want to divide by negative 4. So we have to divide everybody by negative 4. So 2 divided by negative 4 is going to be negative 1/2. So we have negative 1/2 x. And then negative 8 divided by negative 4 is positive 2. And that was not on purpose. I didn't even realize that both of these equations, when we solve for y, ended up being the same. So really, it's going to be the same as a. So my slope is equal to negative 1/2. And my y-intercept is 2. So that's going to be the 0.02. But the point is, you can go from any form of a line, like in this case, the standard form or the general form, to, let's say, the slope, intercept form, or we could go from the point slope form to the slope intercept. So we can write the same equation a few different ways. And let's talk about intercepts, x and y intercept of a line. So the x-intercept is going to be where the line crosses the x-axis. And at that point, y is going to be equal to 0. So if I wanted to find the x-intercept, I would plug in y equals 0 into my equation and solve for x. If I wanted to find the y-intercept, which is where the line crosses the y-axis, at that point, x is equal to 0. So if I were to plug x equals 0 into my equation and solve for y, now I would have the y-intercept, and I could plot that point. So we could also use the intercepts of a line to plot it. So that's what I want to do in example 8. Let's use the intercepts, the x and the y-intercepts, to plot this line, 3x minus 2y minus 6 is equal to 0. So first, let's find the x-intercept. So for the x-intercept, we want to set y equal to 0. So in my equation, I'm going to set y equal to 0 and solve for x. So I'm going to have 3x minus 2 times, instead of y, I'm going to plug in 0, minus 6 is equal to 0. So I'm going to have 3x minus 6 is equal to 0 because 2 times 0 is 0. Let's solve for x. So I'm going to add 6 to both sides. So I'm going to get 3x equals 6. And then divide both sides by 3, and we're going to get x is equal to 2. So the x-intercept is 2, 0. And we could plot that. So that point's going to be right here on the x-axis. Now let's find the y-intercept. And that's when we set x equal to 0. So in my equation, I'm going to have 3 times 0 minus 2y minus 6 is equal to 0. And now we're going to solve for y. So 3 times 0 is 0. So I'm going to have negative 2y minus 6 is equal to 0. Let's add 6 to both sides. So I'm going to get negative 2y is equal to 6. And then divide by negative 2. And y is going to be equal to 3. I'm sorry, negative 3, right? Because we're dividing by negative 2. So my y-intercept is going to be 0, negative 3. And that point's going to be down here on the y-axis. And now I could draw my line. So just another way to plot a line, we can use the x and the y-intercepts. We also could have rewritten this equation that's in standard form, right, or the general form, as y equals mx plus b. And then we could have used the slope and the y-intercept again, like we were doing above. So the last thing we're going to do is an application question. So really a word problem. So we've been practicing all these different concepts, but using, points that aren't really in the context of anything, right? It's kind of just, abstract. Let's apply it to something. So look at example 9. It says use the data points 317, 5704 and 354, 57.64 to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million. Round m to 3 decimal places and b to 1 decimal place. So we're being told that we can use these two data points to obtain, and here's the key word, a linear function. So as soon as we see a linear function, I'm thinking, okay, equation of a line, right? Either y equals mx plus b, or ax plus by plus c is equal to 0, or I could write it as y minus y1 is equal to m times x minus x1, right? So there's different ways we could represent this linear function. But you see how we're given 2 points. We're given the point 317, 57.04. And we're given the point 354, 57.64. Neither one of them is a y-intercept, right? Because neither one of them has an x value of 0. So I can't just find the slope and then plug right into y equals mx plus b, because I don't know what b is. So what I'm going to do is, since I have 2 points, I'm going to use my point slope form of a line. So y minus y1 is equal to m times x minus x1. And I'm going to call the first point x1, y1, the second point x2, y2. But we need to find the slope first, right? We weren't straight out told, okay, this is the slope, but we were given 2 points. So the first thing we have to do is calculate the slope. So we could use y2 minus y1 over x2 minus x1. So we're going to take 57.64 minus 57.04. And we're going to divide that by 354 minus 317. And it says round the slope to 3 decimal places. So once we calculate this, we're going to round it 3 decimal places. So the difference in the numerator is 0.6. And then 354 minus 317 is 37. And when we divide 0.6 by 37, we get about 0.016216, and we want to go 3 decimal places. So this is going to be 0.016 to 3 decimal places. So now that I have my slope, I could plug into my point slope form of a line. So we're going to have y minus y1. So I'm just going to use this point. It doesn't really matter which point you use. I'm just going to use the point that I already designated x1, y1. So I'm going to do y minus y1, which is 57.04. That's equal to m, which is 0.016. Times x minus x1, which is 317. So we're going to have y minus 57.04 is equal to 0.016x. And then now let's take 0.016 and distribute it to the negative 317 by multiplication. So I'm going to have minus 5.072. So now let's write this in y equals mx plus b form. There's nothing wrong with this equation of a line when we leave it in this form, but it's nice to write it, our final answer, in, y equals mx plus b form, because then it's clear to see what the slope and the y-intercept is, and then we could describe the relationship between the two variables. So I'm going to add 57.04 to both sides of the equation. So we're going to get y equals 0.016x. And then I have 57.04. And we're combining that with a negative 5.072. And we end up with plus 51. And it says round B to 1 decimal place. So I have 51.968. So if we round that 1 decimal place, that 9, right, in the 10th spot is going to become a 10 because of the 6 right next to it. So to 1 decimal place, we're going to have y equals 0.016x plus 52. So my slope is 0.016 and my y-intercept is 52. And let's interpret that. So let's go back to the question. So it's saying that we want to model average global temperature. So that's F of X or Y, that's the average global temperature for an atmospheric carbon dioxide concentration of X parts per million. So X is the atmospheric carbon dioxide concentration. So think about this 52. That's the y-intercept, right? So that represents the average global temperature when the atmospheric carbon dioxide concentration is 0, when X is equal to 0. And then the slope, think of this as 0.0. So m is equal to 0.016, right? But we could put it over 1. And that represents the change in y with respect to the change in x. Now, x is the atmospheric carbon dioxide concentration. So for every 1 part per million that the atmospheric carbon dioxide concentration increases, the average global temperature also increases by 0.016. So that's how we can interpret this linear relationship, just by interpreting the slope and the y-intercept. So this is a nice example because it kind of ties everything that we've been doing together in an application question. And that wraps up section 2.3. In the next lecture, we will cover 2.4.